All right, so we're going to continue talking about writing and graphing inequalities, but I just wanted to review what these symbols mean. Remember, inequalities are mathematical sentences that contain an inequality symbol. And you have this one, which is the less than symbol, also can sometimes read in text as is fewer than. Remember last video, we talked about transferring from words or sentences to actual inequality language. And sometimes you're going to see language that looks like this, and that's why I'm including this. You also have is greater than, which can sometimes be phrased as is more than. You also have this symbol, which is less than or equal to, which can sometimes be phrased as is at most or is no more than. And you have the greater than or equal sign, which can sometimes be translated to it as is at least or as is no less than. So these are just words that can be helpful in trying to transfer from text to actual inequality signs. Let's practice a little bit of using these symbols, right? So in here, for example, we have 2.2, which is bigger than 2.15, and therefore we got to go this way, bigger to 2.5, smaller to 2.15. Negative 5 is smaller than 5, which is bigger than it. So you got to go this way. 0.8 is bigger, so you got to go this way. The one that's bigger gets the big chunk. The one that's smaller gets the small chunk. These two are the same. If you try 9 divided by 2 in the calculator, you actually get 4.5. So that's the same. Negative 10, even though the magnitude of 10 is bigger, it is a more negative than negative 8 is. So it's more towards the left in the number line. So it's smaller. Negative 8 wins. It's bigger. It gets the bigger chunk. And 5/8 is bigger than 7/12. If you don't know that, you can do 5 divided by 8 in the calculator and 7 divided by 12 in the calculator and compare them, and you will see that that's the case. So that's just practicing how to use those symbols, right? Now, remember that you can also graph inequalities. This is, again, a review for stuff that we did last week. So, for example, if you're trying to show in the number line, A is smaller than 4, therefore, 4 is bigger than the numbers that we're looking for, but it's not included. So we put an open dot, and then because 4 is bigger than the numbers we want, we go to the left and select them all. On the other hand, if we're trying to graph something like 3 is bigger than or equal to the numbers that I want, that means that the numbers that I want are smaller than 3. But because 3 is included, I'm going to put a closed dot to represent it, and then go to the left again because I am looking for the numbers which are there. And it's sometimes easier to flip the orientation so you can actually see what you need to do, or you can just think it out like I did. But we're looking for points to the left once again. All right? So try to graph this inequality and see if you do that right. So it's a bigger, remember, you can always pause before I show it. And here we go. We do not include the 5 and go to the right because we're looking for numbers bigger than 5. How about this inequality? Well, we're looking for numbers which are smaller than negative 2. So negative 2 needs to be bigger than my numbers, but it is included. So I'm going to shade negative 2 and go to the left. Look the other way to represent that in the screen as well. All right, so here's another example of a word problem being transferred into a symbol. The NASA solar probe can withstand temperatures up to and including 2,600 Fahrenheit. So you would include 2,600, so you need to shade that. But because that is the maximum, you're going to go to the left of that are the temperatures that I can actually tolerate, right? Here's another one, a car designed for ages 12 and up. So how would be the answers? Well, 12 would be included, and then you go up from there. So here's some great examples of graphing representations. How about going from a graph back to actual inequality symbology? Well, the 5 is included here, so it's going to be equal to it, but I also want the things which are smaller than. So I want everything that's smaller than or equal to 5, right? So that could be how you represent this. On this one, I want things smaller than negative 1, but not including it. So smaller than negative 1, not including it, okay? And this one, bigger than 2, not including it. So bigger than 2, not including it. Smaller than negative 5, including it. So smaller than or equal to negative 5. There's supposed to be a negative symbol right there. Sorry about that. Whoops. Okay, so I hope you guys got some good practice on this. We're going to continue something similar to this on the next video. I'll see you guys then.